Mathematics 1, Specimen Examination, Question B1. The line A shows when the blood is leaving the ventricle. Explain in terms of blood pressure why blood does not flow back into the atrium during this part of the cycle. Let's remind ourselves how the heart works. Oxygen deficient blood enters the right atrium here, and it flows through the tricuspid valve into the right ventricle. During this part of the cycle, the muscle walls of the right ventricle are relaxed and it blows up like a balloon. Once the ventricle is full, the muscles start to contract, which causes an increase in blood pressure inside the ventricle, and that in turn causes the tricuspid valve here to close. The closing of the valve stops blood flowing back into the right atrium and forces it along the pulmonary artery to the lungs, where it gets reoxygenated. So blood does not flow back into the atrium because the higher pressure causes the valve to close. Part B, draw a line on the graph to show one complete cardiac cycle. Here's the beginning of one cycle, here's the beginning of the next cycle. So one complete cycle is between those two lines. C, draw a line on the graph to show a period in one cycle when the muscle wall is relaxed. The muscle walls are relaxed during this part of the cycle, allowing the right ventricle to blow up like a balloon. Using your answer to part B, calculate the number of times the heart would beat in 1 minute. One heartbeat goes from here to here. That's to say from 0.2 of a second to 1 second. If the heart were beating once per second, we would have 60 beats in a minute. In this question, however, we've got 1 minus 0.2, so that's 0.8 of a second, so it's beating more quickly than 1 beat per second. So we divide 60, the number of seconds in a minute, by 0.8, which is the time for 1 beat, giving us an answer of 75 beats per minute. Part E. Calculate the volume of blood pumped out by the heart in 1 minute in decimeters cubed. The lowest volume of blood is 64 cubic centimeters. The highest volume of blood is 130 cubic centimeters. So we have 130 minus 64 is 66 cubic centimeters. There are 75 beats in a minute, so 66 times 75 gives us 4,950 cubic centimeters of blood. There are 10 centimeters in a decimeter, so there are 10 times 10 times 10, that's 1,000 cubic centimeters in a cubic decimeter. So we divide this answer by 1,000 to give us 4.95 cubic decimeters per minute.